All right, so we just got done using CUS, or center, unusual features, shape, and spread to compare two distributions. Let's continue on. Gender difference. Which gender is taller, males or females? Most of us probably know that guys tend to be a little bit taller than females. A sample of 14-year-olds from the UK was randomly selected from the Census at School website. Here are the heights of the students in centimeters. Make a back-to-back STEM plot. All right, well, I'm not going to make the back-to-back STEM plot, but I wanted to show you guys a back-to-back STEM plot. So what we do is we put our stems here, and then our leaves go to either side. So the females are on the right side, the males are on the left side. Here, we didn't split the bins up at all, and it's really, for females, there's only 2 rows. That's not that good of a graph. So here, we split the stems into 5 and 5. That looks a little better. And here, we split it into 5 sets of 2 for each of the whatever, right? I personally like this one the best. This one's not too bad, but that first one's not too good. So I just wanted you guys to see that you could compare distributions here. What you got to be careful about is the skewness on these. And I wish I would have made I don't want to make the data skewed because it wasn't skewed, but let's just pretend this was skewed. If this was skewed like this, which way would which direction would the skew be? If you look at it sideways, it looks like it's skewed to the right, to this direction. And that is skewed to the right because these are positive values, so it would be skewed to the right. Now when we go to look at females, usually we flip it around the other way because that's the way the points are. If we were to see something similar like this on this side, you might look at it from the right side and say this is skewed to the left, right? Skewed to the left side. But again, it's skewed to the positive value, so that's not left skewed, that's right skewed. These would both be right skewed to positive values. So when you look at it on one side, it's right, and when you look at it on the other side, it's wrong. Just be careful with that. Histograms. I'm going to pause the video because I got to open up my calculator. All right, so let's talk about histograms. We've already seen them, and they're pretty straightforward, so you probably know kind of how they work. But this is now the formal introduction, I guess. Histograms simply create bins on the horizontal numerical axis, and then we count how many data points are in those bins, and we draw a bar to that height. That's what a histogram is. So if you have your survey data on your calculator, please open it up. I didn't change the year on the notes, my bad, but you should have new data. You should get this. Let's take a look at heights, okay? So to open up a new page, we're going to go Control Document. That creates a new page of that little plus page up there. Or you could hit Control I to insert a new page. And I'm going to open a Data and Statistics page. So this is our default little graph there. And then we click on this lower axis and we're going to plot the heights. So the first thing it creates is a dot plot of heights. So the default is a dot plot. If we want to make a histogram, we go to Menu, Plot Types. These are the 4 types of numerical single variable plots. So we're going to go to histogram. And as you can see, it kind of groups them into bins. In this case, the bins are inclusive 64 to exclusive 65. That's the parenthesis in the bracket. The next one is inclusive 65 to exclusive 66. We got to include one endpoint and exclude the other so that we don't double count the points as we go through here. And you can see in this bin there are 14 points, 13 points, 12 points. You should be using this little mouse pad to highlight those different things. I'm on a computer, so I don't use the mouse pad as much. All right, so what I wanted to show you and what you need to know how to do is you need to know how to modify the bins to get a feel for how that changes the graph and advantage and disadvantage of the histogram. So let's change the bins. Right now the bin width is 1 unit. So let's say I want to change it to 2 units or 3 units. So here's how we do it. You go to Menu, Plot Properties, Histogram Properties. I'm going to go to Bin Settings, and I always go to equal bin width. I've never really played around with the variable bin width. So equal bin widths, that means all the bins are going to have the same width, and we could make it 2. So 2 is going to change the width, and this is going to change the starting value. So if I put it at 2 and I'm at 59, I'm going to go from 59 to 61, 61 to 63. If I change this to 60 or 68, an even number, it'll go from 68 to 70, 68 to 66. It'll go on the even numbers. So both of these are going to change how it looks a little bit. So let's just do the 59. Now, the frequencies are higher because I made the bins wider. So let's grab our axis and pull it down so we can see the frequencies. I could grab the axis here, and I could grab the axis here so I can see all the good stuff. Okay? So this just gives me a blockier picture. I always think of it as like a lower resolution picture compared to the previous histogram, compared to the dot plot, which is like the highest resolution graph we could have. Okay? So if we can see this, it looks like it's unimodal symmetric. We can still pick out shape from this type of graph. But I wanted to set the alignment to 60 instead of 59 to show you that it kind of looks a little bit different. So if we go to Properties, Histogram Properties, Bin Settings, Equal Bin Width. So keep the same width, but now let's change this to an even number. And you could put 60 or 58, or you could put any number. You could put any even number, 66. I'll kind of scale it down and back. Okay. So notice here now on this one, you can kind of see like a little bit of a dip. Like if you're draping that really thin silk sheet across this, you might say it's bimodal. Well, your bin setting shouldn't determine whether a distribution is unimodal or bimodal. So that's kind of a disadvantage of the histogram. And you can even make the blocks even bigger. The bins even wider. Make it really big. Let's make it like 5, which is probably too big, but so it just gives you a really low resolution picture of the graph. Okay. I much prefer dot plots over histograms, but because there's only one, you don't have the different bin settings, and it gives you a nice high resolution view of the graph. Okay, but you are required on the AP test to know how to set it to different bin settings and change those and give different graphs. Okay. Relative frequency histograms, that just puts percentages on the y-axis instead of counts. We can change that very easily on the calculator. If we let's go back to our histogram. Plot type, histogram. Right now it's frequency on the y-axis. If I go to Menu, Plot Properties, Histogram Properties, but instead of bin settings, we go to histogram scale. Now we can change those to percentages. That gives us that there. Okay. Why would you prefer relative frequencies versus frequency histograms? The only thing that I can really think, well, I mean, if you want percentages, then do percentages. If you want counts, do counts. But if I wanted to compare, so let's go back to here. I'm going to undo the change that I just made. So Control Escape to undo. So now I'm in frequencies. So if I wanted to compare heights of guys to girls, for example, I could go to Plot Properties and I could go add a y variable, so option 8, and I could add gender. And these are not too bad to compare because there's about the same number of girls as there are guys. Actually, it looks like there's a little more girls than guys, but they're not too bad. But if I were to separate by handedness, left-handed and right-handed, Menu, Plot Properties, I'm going to add a y variable, option 8. And if I add handedness, It's kind of hard to compare these because there are so many right-handed people and so few left-handed people. So the counts on here are really small and the counts here are really big. That's hard to compare. If I were to switch it to percentages, plot properties, histogram properties, histogram scale, percentages. Now, and I got to rescale this a little bit because I got to see the top. Ooh. Now these bars have equal areas underneath them. They're both represent 100% of the total. So it's a little bit easier to compare. Okay? Not a big deal, but why would you prefer relative frequencies? When comparing data sets that have vastly different numbers of observations, it might be nice. Okay? All right, so make sure you know how to do histograms. Make sure you know how to change the bin settings. But really, dot plots are kind of where it's at. If you look at a dot plot, you can see a higher resolution graph. Okay?